A major product launch is scheduled for 90 days from today. Sales and marketing are locked, but the infrastructure meant to move the product is a disorganized mess. Without immediate intervention, this release will fail before a single unit reaches a customer. Most logistical failures stem from a specific trap, attempting to solve macro design flaws with reactive firefighting on the warehouse floor. Tweaking local packaging lines or shouting at shift leads does nothing to fix a broken architecture. The first step to a successful launch happens long before anyone touches a forklift. It requires defining exactly what the company is promising its customers. You have to decide what your target market actually values. Do they need next-day delivery, or a lower price point, or a sustainable green route? You cannot build the system until you know what that promise is. This data shows why the plan must be specific. This demand history table tracks weekly orders across different retailers. These fluctuating values prove that regional behaviors dictate entirely different logistical responses. Architecting a supply chain without a defined central promise and segmented demand ensures the system will collapse the moment launch pressure begins. Once the strategy is defined, we move to the macro network architecture. This map shows a sparse footprint of centralized warehouses. Centralized hubs offer cheaper storage, but regional hybrids allow for faster delivery. These radiating lines illustrate the complexity of getting product closer to the buyer. Once the warehouse locations are locked, the next sequential gate is establishing a supplier strategy. This requires vetting partners based on their ability to integrate with our logistics data and scale alongside the launch. Selecting partners based strictly on the lowest unit cost creates hidden dangers. True procurement requires evaluating the total cost of reliability and supply chain risk, ensuring a vendor's stability matches the urgency of the 90-day window. Even the most optimized physical network will drain capital if the underlying mathematical rules governing inventory are flawed. Every supply chain operates on an inherent tension. You want to maximize product availability for the customer, but you have to minimize the amount of working capital locked up in unsold stock. We balance this with strict mathematical parameters. This inventory policy interface sets the safety stock, your buffer against sudden demand spikes, and the cycle stock needed for normal weekly turns. Next, we align fulfillment channels with specific demand. Fulfilling a single e-commerce order requires a completely different operational logic than shipping bulk pallets to a major retailer. We then choose our transportation arteries. Air freight offers speed but carries a high cost and carbon footprint, while rail is efficient but slow. Each choice must directly support the original customer promise. Perfectly optimized physical structures and mathematical models will still fail if the system operates blindly without real-time data integration. Efficient logistics require an integrated nervous system of shared data. Without real-time tracking and ERP integration, the right-hand warehouse never knows what the left-hand factory is doing. Disconnected data leads to the bullwhip effect. As seen in this simulation, isolated decisions between the retailer, wholesaler, and factory amplify small demand spikes into massive systemic delays. To prevent this, we stress test the architecture by baking buffers and alternate shipping routes directly into the system to survive variables like weather or labor disruptions. True systemic resilience extends to reverse logistics, transforming returns from a sunk cost into a mechanism for value recovery. The critical final step is translating operational metrics like transport speed and inventory flow into financial outcomes. We need to see how each physical movement impacts the final contribution margin. These final modeled options are presented to executive leadership. They must choose the configuration that balances operational capacity and cost against the promised customer experience. On launch day, as the 90-day clock hits zero, the product flows smoothly. There is no reactive firefighting because the architecture was built to handle the pressure. Operational success is never an accident. A profitable, resilient launch is the direct result of deliberate